Hello and welcome to this episode of Campus 101 exam curriculum series. Today we're going to be looking at molecular theory. And molecular theory is actually, I just coined this term to capture these three questions that are usually asked frequently in your exams. It is regular in your exam and it's very simple. So I just want us to take a look at molecular theory today. My name is Dr. Piro. So under this, we're going to be looking at three main subheadings. The particle theory, the Brownian motion, and then we're going to look at the wave-particle duality of matter. Let me start with the particle theory. What does this state? First, let us start with something we all understand. Matter exists in three forms, all right? Liquid, let me just start this way. Solid, liquid, and gases, all right? Liquid, solid, and gases. Now, this is not for your exam. This is for you to know because you are a physics student. There is another form of matter which we refer to as plasma, and plasma are charged gases. I just want you to know that because you are my student. Dr. Piro's students are excellent students. All right. So, but in your exams, you are going to know that matter is made up of three forms, or exists in three forms: solids, liquids, and gases. But the molecular theory states that all matter, whether solid, liquid, or gases, are made up of, and this is where the theory starts. So the first one says that all matter is made up of particles. So all matter is made up of particles, tiny particles. All matter is made up of tiny particles. The second postulate in the particulate theory of matter states that all these particles that make up a substance, either in its liquid, solid, or gaseous form, and all these particles have energy. Particles have energy. Right? These particles have energy. The next thing I want you to remember clearly is that in the molecular theory of matter is that solids have the least amount of energy. Liquid have some amount of energy. And then gases have the highest amount of energy. All right, so as we move from solid to liquid to gas, the energy level of the particles increase. The fourth one I want you to remember, and this one is important because you are going to use it here and then you are going to use it elsewhere in another video where we're going to be talking about heat. This next point says that the average kinetic energy of the particles of a substance is its temperature. The average kinetic energy of these particles that make up a solid, a liquid, or a gas is its temperature. All right. So with these, we have actually covered what the molecular or the particle theory of matter is talking about. All matter is made up of particles, solid, liquid, or gas. They are made up of what? Particles. The next thing is that these particles have energy. Solid have the least amount of energy, liquid have some amount of energy, and then gases have the highest amount of energy. And then we have said that the average kinetic energy of all the particles makes up the temperature of that particular substance. Are you with me so far? You're not answering me. So pay attention so that we look at the next thing. The next thing we're going to look at is Brownian motion. All right, motion, Brownian motion, Brownian motion, Brownian motion. All right. So what is Brownian motion? And where can we observe Brownian motion? I think that's a more important question. We can observe Brownian motion. We can observe Brownian motion, and listen, there are just two places that I want to tell you that you write in your exam when you see this. We can observe Brownian motion. First of all, Brownian motion explains the particulate theory of matter. We can observe Brownian motion when we put pollen grains in water. What we are going to see when we put pollen grain in water, we see that the particles of this pollen grain, they move in an erratic manner and they collide with one another, and then when they collide with each other, they change their direction, and then they collide with the wall of the container containing them. Alright, so that is what pollen grains do. Another place where we can observe Brownian motion is smoke particles. Smoke particles. When you light a piece or a stick of matches, or when you light a matchstick and you off it, and then maybe let's say it's a dark room, and then you on one tiny stream of light through the smoke. When you see that the particles of the smoke, they move in an erratic manner. That manner is the way is what Brownian motion actually means, and it actually explains the particulate theory of matter in a way. So small particles. The next example I'm going to tell us is the movement of potassium permanganate crystals. All right, if you want to forget this, potassium permanganate, wow, potassium permanganate crystals, the way they move in water also sorts of captures the molecular theory of matter. So far we have looked at the particular theory of matter, we've looked at Brownian motion. I want us to look at the wave-particle duality of matter. Now, the wave-particle duality of matter is a very complex idea, but I'm going to simplify it for us such that we can use it in the exam. When we use it in the exam, we will pass very well, and then we will understand subsequently. The wave-particular duality of matter states that sometimes matter behaves like a particle and obeys all this particulate theory that we've said so far. But we have also noticed that sometimes matter does not behave like a particle, and sometimes it behaves like a wave. A typical example of this is when we study electrons. When we study electrons, we discover that sometimes we can call them particles. I mean, they are subatomic particles, and they have the mass. We can even study their movement, we can study their weight and all that. But sometimes when we want to, in our study of the electron, we discover that electrons don't behave like particles. They actually behave like waves. Let me give you an example that captures it. So, some scientists were studying electrons. So assume this is an atom, then they knocked off electrons from this atom. And when the electron was moving, they were trying to capture where is the electron at that particular point. And we noticed that it behaves like a wave when it's moving. But whenever we put a wall or a barricade along the path of this electron, even though it behaves like a wave, when it strikes the wall at one particular point. This is a very confusing notion, but I just want you to know that sometimes matter behaves like a particle and other times it behaves like a wave. This is very typical of an electron. And with this, we have covered how molecular theory comes out in your exam. In summary, we looked at the particular theory of matter, saying all matter is made up of particles that have energy, and the average kinetic energy is the temperature. We said Brownian motions is seen in pollen grains in water, in small particles, and potassium permanganate crystals. And we said sometimes electrons behave like wave, and then they behave like particles in other times because they are confused, and that makes up the wave-particle duality of matter. See you in the next video.